The transaction log segment streaming subsystem provides time-ordered delivery of write operations to registered subscriber processes. Segments are bounded units of log entries, typically sized between 64 megabytes and 512 megabytes depending on configuration. The streaming layer operates independently of the primary write path, maintaining its own buffer pool and segment index to ensure subscribers receive consistent, ordered views of database state without blocking production writes. Segment boundaries are determined by two criteria: size threshold and time threshold. When a segment reaches its configured size limit or its maximum age interval expires, the current segment is sealed and a new segment is initialized. The seal operation is atomic and non-blocking. Sealed segments transition to the broadcast queue where subscriber processes asynchronously pull entries. In-flight segments remain available for fast-path subscription initialization without waiting for the next seal event. The subscriber registry maintains metadata for each connected consumer, including its current segment offset, delivery state, and subscription mode. 3 modes exist. Replay mode delivers all available historical segments from a specified starting point. Streaming mode delivers only new segments from subscription time onward, and mixed mode initializes from a historical checkpoint and continues with live segments. Each mode has distinct buffer requirements and ordering guarantees managed through the subscription state machine. Delivery acknowledgement uses a watermark-based approach rather than per message confirmation. Each subscriber maintains a committed watermark indicating the highest segment offset successfully processed and persisted locally. The watermark is transmitted to the streaming coordinator at configurable intervals, typically every 5 to 30 seconds. This reduces acknowledgement overhead, while allowing segment cleanup decisions based on the minimum watermark across all active subscribers, preventing premature segment deletion. Buffer pool allocation for streaming follows a predictable pattern based on subscriber count and segment size. The coordinator pre-allocates buffers in blocks corresponding to configured segment sizes. Free buffers are maintained in a segmented list organized by size to reduce fragmentation. When a new segment is sealed, a buffer is dequeued from the free list, populated with entries, and queued for broadcasts. Buffer reuse occurs only after all subscribers have acknowledged processing the corresponding segment. Subscriber connection establishment initiates a handshake protocol. The client sends its subscription mode, desired start offset or timestamp, and client identifier. The coordinator validates the request against existing subscriptions and retention policy. If the requested offset is beyond available segments, an error response specifies the oldest available segment. On success, the coordinator opens a network stream and begins queuing segments for transmission. The initial stream includes relevant metadata headers defining segment structure and schema information. Network transmission uses a batching protocol where multiple segments or partial segments are combined into single frames to optimize bandwidth usage. Each frame is prefixed with a length field and checksum. The streaming coordinator monitors per subscriber throughput and applies backpressure when client receive buffers approach saturation. If a subscriber falls more than 5 segments behind real time, the coordinator optionally transitions it to a compressed or sampled delivery mode to prevent memory exhaustion and maintain system stability. Segment retention policy enforces minimum and maximum age thresholds. Segments older than the minimum retention period may be eligible for deletion once all subscribers have acknowledged processing. Segments younger than the maximum retention period are kept regardless of subscriber status to prevent data loss during transient subscription interruptions. A background retention task runs periodically, evaluates the global minimum watermark, and removes segments that satisfy both age and acknowledgement criteria from the broadcast queue and storage. Subscriber disconnect handling depends on the expected duration. Brief disconnections up to 10 seconds are tolerated without state cleanup, allowing rapid reconnection to resume from the last watermark. Extended disconnections trigger state release, where buffers are returned to the free pool and subscription metadata is archived. Reconnection after extended disconnection requires explicit resubscription with watermark validation. If the subscriber's previous watermark references deleted segments, the subscription automatically initializes from the oldest available segment. Event ordering guarantees within a segment are absolute. Entries maintain their generation order and isolation level semantics. However, subscribers consuming multiple segments may observe partial ordering between segment boundaries due to asynchronous delivery timing. The documentation specifies that application logic requiring strict cross-segment ordering must implement timestamp-based or sequence number-based deduplication. The segment header includes generation sequence numbers enabling clients to detect and handle potential reordering scenarios. The segment index file maintains metadata for sealed segments including offset ranges, timestamp boundaries, checksum digests, and compression type. The index is memory mapped for efficient lookup of historical segments by offset or timestamp. Index entries are immutable once written. A separate journal tracks segment creation and deletion operations, providing audit trail and crash recovery information. Index compaction runs weekly to consolidate journal entries and rebuild optimized index structures. Compression algorithm selection occurs per segment based on entry type, distribution, and configured codec preferences. Numeric-heavy segments may use delta encoding. Text-heavy segments use dictionary-based compression. Mixed segments default to general-purpose compression. The segment header declares the compression codec used. Subscribers transparently decompress on receipt. Compression ratio tracking informs future codec selection. Incompressible segments bypass compression entirely, avoiding processing overhead when compression yields less than 5% size reduction. Error recovery mechanisms handle common failure scenarios. Checksummed entries enable corruption detection during transmission. If corruption is detected, the subscriber requests segment redelivery starting from the last confirmed offset. Network timeouts trigger automatic reconnection with exponential backoff up to a maximum retry interval. If a subscriber becomes unresponsive for longer than the configured timeout period, the subscription is terminated and resources are released, preventing unbounded accumulation of stale subscriptions. Performance monitoring exports metrics including segment seal rate, average segment size, subscriber count, delivery latency, and buffer pool utilization. These metrics are sampled at 1-minute intervals and stored in the metrics database. Latency percentiles at the 50th, 95th, and 99th levels provide visibility into tail behavior. Alert thresholds can be configured for buffer utilization above 80% or subscriber lag exceeding 10 segments. The monitoring subsystem operates independently to avoid impacting streaming performance. Configuration parameters include segment size bounds, time thresholds, retention windows, compression codec selections, and network buffer sizes. All parameters are mutable at runtime through the Configuration API. Parameter changes apply to subsequently sealed segments without disrupting active subscribers. Historical segments retain their original configuration settings. Configuration changes are persisted to the configuration repository before applying, ensuring durability across coordinator restarts. The transaction log segment streaming subsystem provides consistent, ordered delivery of database operations to distributed consumers. By decoupling subscriber delivery from primary write operations through asynchronous segment broadcasting, the system maintains write performance, while enabling reliable, ordered consumption by arbitrary numbers of clients. Proper configuration of retention policies, subscriber monitoring, and resource limits ensures stable long-term operation across diverse deployment scenarios.